Chapter 6, Section 1, Complex Numbers. In this section, we're going to learn how to deal with complex numbers or imaginary numbers, and this is going to come from when you take the square root of a negative number. In the previous chapter, we learned how to deal with square roots and cube roots, but we said that you cannot take the square root of a negative number and get a real solution. Instead, your solution is going to be imaginary or complex. So, if we have a problem such as this, x squared is equal to negative 4. This has no solutions in the set of real numbers, but it does have a solution in the set of complex numbers. And so it's just a different set of numbers. We're going to learn to work with these numbers just like we did with regular integers in the real set. So, an imaginary number is denoted with an I. So if you have to take the square root of negative 1, anytime you take the square root of negative 1, what you're going to do is you're going to replace the square root of negative 1 with an I. These two are equal to each other. Also, if you have to, when you're multiplying, and anytime you get an I squared, so for example, I is just a variable, so anytime you have I times I, you're going to get I squared. And anytime you get I squared, you can replace that with negative 1. So, these two you need to memorize. The square root of negative 1 is equal to I, and I squared is equal to negative 1. And we're going to replace these when we can. So, for example, what if we're asked to take the square root of negative 49? Well, you know that you're not going to get a real number, you're going to get an imaginary number, so there is going to be a variable of I in there somewhere. Well, just like in Chapter 5, we broke the square roots into products. Well, I can break this into negative 1 times 49. And so basically what I have is the square root of negative 1 times the square root of 49. And the square root of negative 1 is I times the square root of 49 is 7, and so you get 7I. Same for letter B. If you have the square root of negative 45. The negative is going to go to negative 1 times, and then 45, since we can't take the square root of 45, we have to think of perfect square factors that go into 45, and that's going to be 9 times 5. So the square root of negative 1 is I. The square root of 9 is 3, and you can't take the square root of 5, so it has to stay under the radical. So you're going to get 3I square root of 5. And again, I is just a variable, so if you know that if you do x times 3, you're going to get 3x. Same thing with your variable of I. Okay, so a complex number is any number of the standard form a plus bi, where a and b are real numbers, and the real part of the imaginary number is a, while the imaginary part is b. So if I ask you to write your complex number in standard form, and when you check your answers in the back of the book, you're going to see the answers written in standard form as well. So anytime you're missing one of these parts, instead of just writing the real number or the imaginary part, in order for it to be in standard form, you have to have the real and the imaginary part. So if something's missing, you're going to see, for example, something like if the real part's missing and you just get an imaginary number, such as this 7I, to write this in standard form, you would have 0 plus 7I. Because there's not a real number, so you just write the 0 for that. And if there's not an imaginary number, then you write a 0 for that as well. Okay, so adding and subtracting these complex numbers, you're going to do this the exact same way that we did in Chapter 3. To combine complex numbers simply means to collect like terms. So you're going to have the real parts, 3 plus a negative 2, and I know it's addition because the plus sign in between. So 3 plus negative 2 is going to be 1. And then 5i plus a negative 7i is going to be negative 2i. And that is in standard form because I have the real first and the imaginary second. Now we're going to subtract, and I know that because of the minus sign in between the two groups. So you have your real parts, negative 4 minus 2 is going to be negative 6, and then I minus a negative 5 turns into I plus 5i, which is going to give me 6i. And this I does have a coefficient of 1, so that's where that comes from. Okay, so to multiply complex numbers, this is where you're going to get this I squared, so be very careful with that. If it's in radical form, express it first as a complex number. Don't forget this. I know that you can multiply radicals, but that's only for real numbers. So if it's in radical form and you know it's going to be a complex number, you have to write it as a complex number first. In other words, if you have a negative underneath a square root, you have to write it as a complex number first. Then you can multiply, you can find the product. If it's already in complex form, then you're just going to carry out multiplication like we did in chapter 3. Please don't forget, if you see an I squared, you're going to replace it with -1. It's going to help you simplify these things. Okay, so for example, you see the negative underneath a square root, and so you know that this is not a real number. This is going to be a complex imaginary number. So we have to fix this. So you can't multiply the square root of -16 times the square root of -81 because, like I said, they're not real numbers. Instead, what we're going to do is we're going to write these as imaginary or complex numbers. So, for example, the square root of -16, you know, is going to break down into -1 times 16. And the square root of -1 is I, and the square root of 16 is 4, so we get 4I. So now that that's written in complex form, we can multiply that. Same thing with square root of -81. Square root of -81 is going to turn into 9I. And now we can multiply these together. So 4 times 9, your coefficients, 4 times 9 is going to be 36, and I times I is going to be I squared. But remember, I squared is the same as -1, and so you're going to get a -36. Okay, so letter B, we can't take the square root of 5 and we can't take the square root of 10. So what are we going to do? You have to get that negative out from under the radical first. So this is going to turn into -1 times 5. The square root of -1 is I, and you can't take the square root of 5. So that one's fixed, and this one's going to turn into I square root of 10. And now on the outside, I times I is I squared, and since the numbers left underneath the radical are real numbers, I can multiply these now like we did in chapter 5. So the square root of 5 times the square root of 10 is going to be the square root of 50. And then we need to simplify this. I squared, as you know, is -1, and then 50 will break down into 25 times 2. So you're going to have -1 times 5 times the square root of 2. So all in all, you get -5 square roots of 2. Alright, distributive property. Again, these are already written in complex form, so we can just use the distributive property like we learned in chapter 3. So 2i times 4 is going to be 8i, and 2i times -3i is going to be -6i squared. And of course we have to simplify this because you know this I squared is the same as -1. So you're going to have 8i minus 6 times -1. So you're going to have 8i plus 6. But to write it in standard complex form, the real needs to come first. So we're just going to flip-flop those and get 6 plus 8i. Alright, what about a binomial times a binomial? That's the full method. So you're going to take the 5 and multiply it through that second group. So 5 times 3 is going to be 15. And 5 times -7i is going to be -35i. And then you're going to take the 2i and multiply it times that second group. So 2i times 3 is going to be 6i. And then 2i times -7i is going to be -14i squared. So let's simplify where we can. We have 15, can't do anything with that, but this -35i and this positive 6i is going to give me -29i. And then the minus 14i squared is going to turn into -14 times -1. So continue to simplify. We're going to get 15 minus 29i plus 14, and now we can put these real numbers together. And so we're going to have 29 minus 29i. Okay, so remember when we had something like 2 over the square root of 5, and we needed to get that radical out from under the denominator, so we've multiplied the top and the bottom by the square root of 5. And so we have 2 square roots of 5 over 5. Well, when you see I, remember I is the same thing as a square root, so you cannot have an I in the denominator. Well, to get rid of that, we're going to multiply the top and the bottom by I. So on the top we'll have 3i, and on the bottom we'll have 10i squared. Now when you do this, don't cancel out the i's because that's going to take you back to the beginning. But instead, we're going to turn that I squared into a negative 1. And so we'll have 3i over negative 10. And then of course you could simplify if it would, but the 3 and the 10 won't simplify. So this is your answer. Okay, same thing here. I need to multiply the top and the bottom by I to get that I out of the denominator. On the top, that's the distributive property. So I times negative 2 is negative 2i. And I times 6i is going to be 6i squared. And then on the bottom we have 3i squared. So fixing this where we can, we're going to have negative 2i minus 6, because remember I squared is negative 1, negative 6, negative 1 times 6 is going to be negative 6. And then 3i squared is going to turn into negative 3. Again, remember, I squared is negative 1 and 3 times negative 1 is negative 3. Algebra etiquette says that you can't have a negative in the denominator, so if you want to fix that, they probably will in the book, but I'm not going to worry about it. Okay, conjugates. Remember back in chapter 5 when we discussed conjugates, and you have to remember what we just talked about on the previous section, or the previous slide, versus this slide. It's the difference in this versus this. So on the one on the left, since it's a monomial in the denominator, all I have to do is multiply the top and the bottom by the square root of 5. But on the right, since my denominator is a binomial, in order to get rid of that radical, I have to multiply by the conjugate, which means I'm just going to change that sign in between the square root of 5 and the 2. So, same thing with your imaginary numbers. If you're dealing with just a monomial, all you have to do to get rid of the I is multiply the top and the bottom by I. But if you have a binomial, you have to multiply by the conjugate. And notice the product of conjugates is always going to be a real number. Okay, so find the quotient and express in standard complex form. Alright, so here I have an I in the bottom, but I also have a binomial, so I need to multiply by the conjugate this time, so we're going to have 5 plus 3i on top and bottom. So when I multiply the top and the bottom by 5 plus 3i, on the top, that's your distributive property, so 2i times 5 plus 3i. 2i times 5 is going to give me 10i, and 2i times 5 is going to give me 10i, and 2i times 3i is going to be a positive 6i squared, so you already know what we're going to do there. And then on the bottom, you can full this out, but since it's a sum and difference, technically all you have to do is first times first. 5 times 5 is 25, and then last times last. Negative 3i times positive 3i is negative 9i squared. Alright, let's simplify. You can't cancel, but we can simplify. So we'll have 10i minus 6 over 25 plus 9. Remember, when you see that I squared, you're multiplying by negative 1, which changes the sign. Hopefully you're catching on to that. And then to write it in standard form, we're going to have negative 6 plus 10i over 25, and 9 is going to be 34. And then another thing that you need to remember here is this will reduce. We discussed this in chapter 3, and we also discussed it in chapter 4. Since the bottom is a monomial, all three of these can reduce by 2. And so 2 will go into negative 6 negative 3 times. 2 will go into 10i 5i times. And 10 will go into 34 17. And so now that's in reduced standard complex form. Okay, the one on the right, I have the I in the denominator, so I need to multiply by negative 2 minus I. So again, remember your conjugate is just changing the sign in the middle. It has nothing to do with the sign up front. It's just changing the sign in the middle. So on the top, this time, over here on the left, all we had to do was the distributive property. But on the right, we have the whole entire full method, and it's not a pattern, so you have to distribute the whole way through. So negative 2 times that group. Negative 2 times negative 3 is going to be 6. Negative 2 times 8i is going to be negative 16i. And then take your negative I through the group. Negative I times negative 3 is going to be positive 3I. And negative I times positive 8I is going to be negative 8I squared. And then on the bottom, now this is your pattern. It is a sum and difference, so you can do first times first and last times last. So negative 2 times negative 2 is going to be positive 4. And negative I times positive I is going to be negative I squared. Alright, so let's simplify where we can. We're going to have 6 minus, these two can be put together, negative 16I and positive 3I is going to be negative 13I. And then the negative 8I squared is going to turn into a positive 8. And then on the bottom we're going to have 4 plus 1, because there is a 1 here. But that I squared is going to turn it into positive 1. Combine our like terms and write it in standard form. So 6 and 8 is going to be 14 on the top. So you have 14 minus 13I. And on bottom we have 5. And all of these won't reduce by the same number, so that is going to be your answer. So what I'd like for you to do is I'd like you to try these problems on page 302 and bring them into class if you have any questions.